Hello everyone. This video demonstrates a use case on TinyML. Before we get into the demonstration, let me introduce you all to TinyML. Tiny machine learning is an emerging field that is at the intersection of machine learning and embedded systems. An embedded system is a computing device that usually is tiny and which operates with low power, so much so that some of these devices can run for days, weeks, months, and sometimes even years on something like a coin cell battery. TinyML is a type of machine learning that shrinks deep learning networks to fit on tiny hardware. It brings together artificial intelligence and intelligent devices. Edge computing brings computation and data storage closer to the origin of data. Majority of the edge devices that integrated with IoT-based ecosystems are initially designed to collect sensor data and transmission of the data to neighborhood or remote cloud. In this particular demonstration, machine learning is used to build a gesture recognition system that runs on a microcontroller. This is a hard task to solve using rule-based programming, as people don't perform gestures in the exact same way every time. But machine learning can handle these variations with ease. So, the first and the foremost step is to install the dependencies. So, the software tool used here is Edge Impulse, and it is a cloud service for developing machine learning models in the TinyML targeted edge devices. To set hardware up in Edge Impulse, you will need to install the following software. So, to continue installing Edge Impulse, we need to install Edge Impulse CLI, which is a command line interface to communicate with Edge Impulse. First thing we need to install is Python. So, as we reach on the home page of Python, you can see the download version over here. Make sure that you download a version 3 or greater on your host computer. As you click on the link, it will lead you to the installation link for Windows and various other operating systems. Next, you need to install Node.js version 14 or higher on your host computer. Mostly it is written which one is recommended for users. One point to note while installing Node.js is there will be a pop-up which gives you an option to install the additional Node.js tools. So ensure that the box is checked and then click the next button. Before completing the installation of CLI, we need to create an Edge Impulse account. So as we go to the Edge Impulse website, many of their CLI tools require the user to log in to connect with the Edge Impulse Studio. So make sure to create an account or sign up with Edge Impulse. Next, we install the CLI tools via the given command on command prompt. And once done, you should now have the tools available in your path. The next step is installation of desktop version of TiUniFlash. Now this is a standalone tool used to program on-chip flash memory on TI MCUs. Once you open this link, you can see the homepage of TiUniFlash, and you will go to the downloads section of TiUniFlash. Install according to your operating system. Next, and the very important thing you need to do is add the installation directory to your path. Now, as you go to the settings of your operating system, you will find an option to edit the environment variables. Select the option of path variable under the system variables as we click on the environment variables. And once you select the option of path, you can add the directory path in here. Click OK, and you are done with adding the installation directory. Now if the UniFlash CLI is not added to your path, the install scripts will fail. To fix this, you have to add the installation directory to UniFlash. Now this is the TI Launchpad, or the hardware which we will be working on. This is the TI CC1352P Launchpad, which is a development board equipped with multi-protocol wireless CC1352P microcontroller. The Launchpad, when paired with this Boost XL sensors, is fully supported by Edge Impulse and is able to sample accelerometer and other sensor models and deploy them directly onto the device without any programming required. With all the software in place, it's time to connect the development board to the Edge Impulse. So once you connect the development board to the Edge Impulse, we need to update the firmware. The development board does not come with the right firmware yet. So to update the firmware, download the latest version of Edge Impulse firmware using this link. This link will download a zip file which will have these following files in it. Open the flash script for your operating system and we will flash the firmware accordingly. Wait until flashing is complete and press the reset button once to launch the new firmware on the hardware. The following video shows the demonstration of the same. So as you can see, we have opened the flash script and the hardware is flashing. Once the flashing is done, your new firmware will be uploaded on the hardware after pressing the reset button. So this is how we'll press the reset button. Next thing we will be doing is we need to run few commands on command prompt. So as we can see here, we have to run a command called Edge Impulse daemon, and this will start a wizard which will ask you to log in and choose an Edge Impulse project. So you will be logging into your Edge Impulse account. You will also be asked which device do you want to connect or which port do you want to connect. So the Launchpad enumerates two serial ports. The first is the application user UART, which is the Edge Impulse firmware communicates through. The other is an auxiliary data port which is unused. Generally select the lower numbered serial port. This usually corresponds with the application or user UART. On Windows, the serial port may also be verified in the device manager. So once you select everything, you need to select which project you want to connect to. So there might be multiple projects on your account. You can connect to a single project and then just move ahead. When you open the Edge Impulse website, this is how the dashboard looks like. It shows which project you are connected to. Now, next thing you have to do is verify whether the device is connected or not. And to verify if the device is connected or not, we need to go to the devices section. As you can see, the devices which are connected will be listed over here. With your device connected, we can collect some data in the studio, and we need to go to the data acquisition tab. This is the place where we will record the raw data, and under the record new data, we need to select the device. Also, set the label to up down, sample length to 10,000, which is 10 milliseconds, which is 10,000 milliseconds, and that is 10 seconds. The sensor to built-in accelerometer, and the frequency to 62.5 Hz. This indicates that you want to record data for 10 seconds and label the recorded data as up down. You can later edit these details or labels if needed. After you click start sampling, move your device up and down in a continuous motion in above 12 seconds, and the device should complete sampling and upload the file back to Edge Impulse. Machine learning works best with lots of data, so single sample won't cut it. Now it's time to start building your own data set. For example, use the different classes to record around 3 minutes of data per class, and these classes will be idle class, snake class, wave class, and up and down class. Now we will see the demonstration for the same. As we have selected up and down data, we will start sampling for the same. Move the board in the up and down movement. Try to move in as many possible variations so that it can record a variety of data for up and down segment. Next, we'll change the label to wave, and this is how we will wave the board. So as the accelerometer on the development board has 3 axes, you will be noticing 3 different lines, one for each axis on the graph of the raw data. Next data we will be collecting is the snake type of data. So snake is basically moving the device over your desk as a snake. Last one is the idle type of data, and in the idle type of data all you have to do is keep the board in an idle position and start sampling. So this is how you will sample for all classes. So alternatively, you can also load an example test set that has about 10 minutes of data in these classes. So these show you the alternative ways of collecting data on Edge Impulse. You can upload the data to existing data sets in the following type file formats. Next part is to create or design an impulse. While the training set is in place, you can design an impulse. An impulse takes the raw data, slices it up in smaller windows, uses signal processing blocks to extract features, and then uses a learning block to classify new data. The signal processing block applies a filter, performs spectral analysis on the signal, and extracts frequency and spectral power data. Then the next thing we will be using is the neural network learning block. That takes these spectral features and learns to distinguish between the 4 classes, which are idle, snake, wave, and up and down. To configure your signal processing block, you need to click spectral features on the menu on the left, and this will show you the raw data on the top of the screen. You can select other files via the drop down menu over here, and the results of the signal processing through graphs on the right. For the spectral features block, you will see the following graphs. Now, these are various graphs we can see. So the after filter block or the graph is the signal after applying a low pass filter, and this will actually remove noise. The frequency domain is the frequency at which the signal is repeating itself. Also, the spectral power is the amount of power that went into the signal at each frequency. A good signal processing block will yield similar results for similar data. Now, if you move the sliding window up around the graph, you should find the data or the graph should remain similar. Next, the feature generation screen. As you can see in here, you'll split all the raw data up, and based on the window size and window increase, the data will be splitted. We'll apply the spectral features block on all these windows, and then we'll click generate features to start the process. After the feature explorer will load, this is all of the plot of all the extracted features against all the generated windows. You can see the graph to compare your complete data set. Example, by plotting the height of the first peak on x-axis, while plotting other particular features like spectral power or height of the peak on other axes. A good rule of thumb is that if you can visually separate the data on number of axes, then the machine learning model will be able to do so as well. With all data processed, it's time to start training a neural network. The network that we are training here will take the signal processing data as an input. So, this will try to map to all other classes or all the 4 classes we have defined before. A neural network basically consists of layers of neurons, all interconnected, and each connection has a weight. One such neuron in the input layer would be the height of the first peak of x-axis, and one such neuron in the output layer would be the wave. So that way it will be mapping the classes. When defining the neural network, all these connections are initialized randomly, and thus the neural network will make random predictions. During training, we then take all the raw data, ask the network to make a prediction, and then make tiny alterations to the weights depending on the outcome. And this is why labeling the raw data is important. This way, after a lot of iterations, the neural network learns and will eventually become much better at predicting new data. So as we can see by the number of training cycles, the accuracy for the same goes to 99.7% and the loss goes to 0.01%. So here we can see the accuracy actually can vary with varying training cycles. This is the confusion matrix, and the confusion matrix gives the details of what percentage of data is correctly detected, and which is also shown in the form of graph. So it shows labels for correct data and incorrect data with all the indications on the graph. So here we will see a demonstration on how to classify or how to do live classification. So this is the live classification of up and down data, as we need to see how the neural network performs on new data. As we set the sample length and start sampling and start doing movements, we can see it will be able to detect the proper output of the data, and as we did the up and down movement, it is detecting the output in the form of up and down in the graph as well as in other report. Next part, with the edge impulse being designed, trained, and verified, you can deploy this back to your device. This makes the model run without an internet connection, minimizes latency, and runs with minimum power consumption. Now, edge impulse can package up the complete impulse, including the signal processing code, neural network weights, and classification code in a single C++ library that can include in your embedded software. But since we are using a network or a hardware which already has an uploaded firmware of itself, we do not have to upload any new C++ library. In this, we will be looking into the demonstration of the deployment of the model on the device. So as we scroll down, we can find an option for TI Launchpad CC1352. As we select the Launchpad and click Build, this will export the impulse and build a binary that will run on your development board in a single step. So after building is basically completed, you'll get prompted to download a binary. Now I have a binary file already downloaded. So as we open the binary file, the firmware will be uploaded on the hardware. This is where the firmware or the network model is getting uploaded on the hardware so that it can run the required application. Now all you need to do is run a command called edge impulse run impulse. As you run this command, it will prompt to select the COM port. As you select the COM port, you can finally see the output. So as we move the board up and down, we can see the up down is showing some data. So the up down data is collected. This is the snake data, and in the output we can see some value in the snake classified. Next, we have the idle form of data, and we can see there's a value in the idle. Next, we have the wave form of data, and again this will show you a value besides wave. So this is how data is being classified. Now when you click the build button, you will see a pop-up with text and video instructions on how to deploy the binary to your particular device. Follow these instructions, and once you're done, we are ready to actually test your impulse. So this is how we have tested our impulse on the command prompt. Next, this is just a slide to show you how the output is being predicted or classified. So as we can see, there are various values for various form of classifications, and the highest value for that particular classification is the actual classified answer for the input. Now this will sample data from the sensor, run the signal processing code, and then classify the data. This is how the whole process is done. And that's how machine learning is implemented on an edge impulse. Thank you.